Okay, guys and girls, so what we have here, I'm just going to give you a summary of what we're going to be looking at in this section. We're going to be looking at a structure of the atom. We're going to be looking at the relationship between groups and electrons, uh, between periods and the number of shells, and we're going to be looking at ionic bonding. Okay, so it's going to be a big topic, but I want to get through it. In fact, I might split it up. I might just do structure of the atom, groups and electrons, and then the big. No, I won't. I won't. Okay, I lied. Actually, I might. We'll see. We'll see. Okay. So anyway, looking at this, what we've got is we've got lithium again. Now I'm using lithium because we used it a lot, so it's something that we're gonna get familiar with. But if you look at lithium, it's got a top number of 7 and a bottom number of 3. Now, as we said in the previous video, the top number represents the relative atomic mass, and I've highlighted the word mass. The reason for this is because this shows that it's gonna be composed of the heaviest things. And if you remember the definition of relative atomic mass, it's the number of protons and neutrons. So what we can know is that the protons and the neutrons is what gives it its mass. So when we're filling in this table, the mass of the protons and the neutrons is going to be the heaviest. So that's 1, 1. The electrons will have a negligible mass. Okay, so it's hardly anything at all. So just by the definition of relative atomic mass, you know that the mass is the protons and the neutrons. Now, the charge of the proton is going to be positive 1. Okay, now guys, note it's just the charges that have positive and negative numbers, not the mass. Okay, we don't say that you have a mass of plus 50 kg or a mass of minus 50 kg. No, we say you have a mass of 50 kg, right? A charge, however, has charge. Obviously, charge has a charge, positive and negative charge. So the charge of the proton is positive, and the charge of the electron cancels the charge of the proton, so it's going to be the opposite. So the protons are positive, and if you remember that protons have a positive charge, and if you go in a positive mood, that's a plus thing, isn't it? So protons have a positive charge. If you're in a positive mood, that's a plus thing, so that's a positive charge. Electrons, now guys, once you get to college and university, whoever takes up science, the short way of writing electron is that. So you got an E with a negative sign at the top. So that tells you that the electron has a negative charge. That's how you remember. And once you get to college and university and you're still taking science, you're going to write that as shorthand for electron, E with a negative charge. And neutron has no charge, so neutron has no charge. That's 0 charge. Now, where are they found in the atom? Okay, so the protons and the neutrons are found in the nucleus. Okay, so that's a proton, for example. I'm just making this up. Okay, and the electron are found in the electron shells. So the protons are found in the nucleus. This bit here is called the nucleus. So this is the nucleus for the proton, nucleus for the neutron, and these electrons are found in the electron shell. Okay, so that's pretty straightforward, I think. So the next thing we're going to be looking at, that I said, is the relationship between the group and the number of electrons. Okay, so I'm just going to get rid of all of this. Off you go, off you go, off you go. I'll increase the opacity of my periodic table. So, if you look at here, guys, what I want to show you is that this is group 1, right? So decrease that. This is group 1, as we've already said. Now, group 1, all of this is group 1, right? The outermost electron will be 1. Okay, so in the outer shell of group 1 elements, you're going to have 1 electron, right? So in the outer shell of group 2 elements, so all of this is group 2, in the outer shell of group 2, how many electrons are you going to have? You're going to have 2 electrons, right? In the outer shell of group 3, you're going to have how many electrons? you're going to have 3 electrons in the outer shell of group 3. In group 4, how many electrons are you going to have in the outer shell? You're going to have 4 electrons in the outer shell. Group 5, you're going to have 5 electrons in the outer shell. Group 6, you're going to have 6 electrons in the outer shell. In group 7, you're going to have 7 electrons in the outer shell. In group 0, also known as group 8, you're going to have 8 electrons in the outer shell. So what does this mean? Let's take lithium again. Okay, so lithium is 7 and 3, right? It's in group 1. I'm going to draw lithium as an electronic structure. I've got 2 on the inside. We've already covered this last video. And I've got 1 electron on the outermost shell. Now you can take any of these, and on the outermost shell there'll always be 1. Now let's prove this with neon. Okay, so neon, which is this one here, has a number of 20 at the top and 10 at the bottom. Now obviously we're working with the number of electrons, so we've got to use the bottom number. So if I just get rid of this image, so it's Ne 10 and 20, and remember this was in group 8 or group 0, same thing. Okay, so it should have 8 electrons in the outer shell. So I've got neon Ne, here's my first shell, so I've got 2 electrons in here, right? I'm going to draw another one, and I've got just 2 in total, 3, 4, 5, 6, 7, 8, 9 and 10. And can you see it was in group 8, and the total number of electrons on the outermost shell is 8. So that proves what we were saying. So the relationship between the group number, so the group number will show you how many electrons in the outer shell. Yeah, so group 5 will have 5 electrons in its outer shell, etc, etc, etc. So now let's look at the relationship, and this is, guys, this is all important for ionic bonding, so it's not something random, okay, and you'll see why later on. So if you look at the relationship between the periods, and so this is period 1, yeah, helium and hydrogen. This is period 2. Remember, periods go across, they make periods make a girl go across, so periods are across. Now if we take hydrogen, right, what we're going to do is we're going to draw its electron structure, right? So the hydrogen is period 1, remember, so hydrogen is in period 1. Now it's got 1 electron inside the shell. So if you look at period hydrogen in period 1, how many electron shells does it have? 1. Now we're going to take something, anything from period 2. Let's go with nitrogen. Okay, so nitrogen has a top number of 14 and a bottom number of 7, and it's in period 2. Can you see it's in period 2? So let's draw nitrogen. So it's got, we're looking at the bottom number because that's the number of electrons, so it's 1, 2, we'll draw the next shell, 3, 4, 5, 6 in total, 7 in total. So I've got 7 electrons in total now. And can you see period 2 has 2 shells, 1 shell here, 1 shell here. Guess how many shells period 3 is going to have? That's correct, it's going to have 3 shells. And I'm going to take a random one that we haven't done already. I'm going to take magnesium. Okay, so I'm going to remember magnesium is in period 3. So this is period 1, this is period 2 going across, this is period 3 going across, and I'm taking one from period 3, so I'll take magnesium, and let's see what magnesium does. So magnesium is 24 and 12. So magnesium is 24 and 12. Now we're using the bottom number because we're looking at the number of electrons. The bottom number equals the number of protons, which happens to equal the number of electrons. So let's do this now. So magnesium at the first 2 is 2 in the first electron. Let's count the total number of electrons. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay, so now if you look at this, it's in group 2, magnesium, it's in group 2, so it's got 2 electrons in its outer shell, and it's in period 3. So period 1 is here, period 2, period 3. It's got 3 rings. 3 electron shells rather. So what's the relationship between the period? So the period number is equal to the number of electron shells. So that should clear that up. Okay, now I'm gonna stop this video just to make it short as possible, so it's not too painful to watch. None of my videos are painful to watch, by the way. They are all amazing, obviously. And then I'm gonna. Now, guys, remember this is linked to the next bit that I'm gonna do. So I'm gonna stop this. We're gonna move on, but it is linked, so don't think that I'm stopping because it's not linked. It's linked to the next bit, but I don't want the videos to be too long and boring and whatever, because we've already had a 22-minute video, so I think this is a good place to stop.